Hey there, here is my little teach back about weights and their role in neural networks. Basically, using our training data, we map input values to output values using our weights. This training data helps our network find patterns in the numbers to make more accurate predictions for the future, which is very important whenever you're making any sort of neural network. You want your predictions to be accurate, obviously. But what I struggled with at first was how do our neural networks know which weights to use? It's actually kind of funny, pretty simple. It's random. It just picks a random number at first and then goes from there using different methods and algorithms and stuff to fine-tune the weights. But on a very base level, I made a little bit of a instructional kind of demonstrating like how it's used in the network. Mind you, this doesn't include any biases, it doesn't include any activation functions or anything like that. But in simple terms, say we have our last year's sales and we're trying to figure out how to match them up to this year's sales to provide accurate futures for our new data. It's as simple as multiplying our input by our weight to equal the output. Now in this little example here, the perfect weight would be 2. Unless our algorithm guessed that first, it wouldn't be accurate. So we'll give a brief look on how it'd figure that out. So say for our weight, it chooses a random value of 1.5. You start with your input layer of the 2. You're going to multiply it by that weight of 1.5, which comes to an output layer of 3. Since it's not actually our desired output of 4, what we do is we subtract our target from the output layer, which comes with our error and loss. Now what our neural network wants to do, it wants to get our total loss as close to 0 as possible, because that's going to show more accuracy. If it's a total 0, then that's it thinks it's 100% accurate with its prediction. And now this number can actually go positive or negative, but a true 0 is going to be the most accurate. I kind of move on here. Our total loss from our first example came to 2.5. Now that's not terrible, but it can definitely be better. So now our program updated our weight to 1.75, which comes to a total loss of 1.25, which is actually a lot better. Still can be improving, but as you can see, the weights have a pretty big impact on how accurate our data becomes. I wanted to take a little bit of a step further, and I made a little program to kind of demonstrate how adjusting the weights affects our predictions as well. So you start off, you enter how many data entries you want to use. So I'll do 3 for now. And it just pulls up some random values and weights for it, assigns the weights to them. So as you can see, our weighted sums equal 0.56, which is over our threshold of 0.5. So it gives the output of 1. Say we wanted our output to actually be 0. Let's go ahead and adjust our weights. And what we need to do is decrease them since it's above our value. So let's go ahead and enter decrease. And as you can see, our previous weights here and our new weights. So there you go. So that adjusts it. It's now below our threshold to 0. I hope that gives a little bit of a better explanation from me. Making all this definitely helped me understand weights a little bit better. You guys have a good rest of your day.